Just a bit maybe of a quick background about Indeni. Indeni's been around for several years as a company. Started it a few years ago. And initially we were building and selling a product around automation for security infrastructure. So if you think about those firewalls and web security gateways and load balancers that people have in their networks in the data center, we built a product that does automation on that. So if you kind of think about it, just like Terraform,
but not Terraform based.
Exactly, not Terraform based. Just like Terraform has all these providers for AWS and GCP and Azure and anything you want, even submitting your application for a job. We kind of built a similar concept for the world of security infrastructure. And that product is in use by some of the largest organizations in the world, airlines, credit card companies, and many, many others. And as we've been working with these companies and building our own cloud environment, we started getting more and more into infrastructure as code. Initially CloudFormation and then Terraform. And Terraform has been amazing. So, you can obviously debate the advantages and challenges of Terraform, and we often do it here on these sessions. But Terraform is taking the world by storm, over 100 million downloads, as we've seen in their blog post yesterday and their announcement as well. And so when we were talking with customers about how they were using Terraform, we specifically were talking to them about the security aspects of using Terraform and the security and the general cloud security aspects. So let's say you've got AWS or Azure and you want to deploy something there. How do you make sure that whatever you're deploying is secure? How do you make sure that your company is not the next one to show up in the news as being hacked? And so when we were talking to customers about this, they were talking a lot about CSPM tools. They said,
what does that stand for?
Yeah, so CSPM are cloud security posture management tools. So it's things like
that category.
What? Sorry?
I never heard of that category.
Oh yeah, it's it's all the rage at Gartner.
Okay.
No, but there's actually like 70 different tools that call themselves CSPM. So you could have things like Dome9 that are now a Checkpoint, Prisma Cloud by Palo Alto Networks, Rapid7.
Open source.
Prowler. You got Prowler. Cloud Custodian could be looked at as a CSPM tool as well.
Okay.
There are a lot of open source, and then there are also the services offered by the cloud providers, what's called the CSPs. So AWS, for example, has Guard Duty, which falls under the concept umbrella of CSPM. Azure has the policy, Sentinel, etc. That also, well, mostly the policy aspect falls under the CSPM, and they actually call it CSPM in Azure. And really, every single cloud provider have their own kind of solution for CSPM. Now, the trouble with cloud security posture management historically has been that it finds issues in your live environment after it's already built. So let's say I'm building an application and there's the infrastructure side of things, and I'm using Terraform, I'm using the cloudposse modules, and I've got an S3 bucket, a database, a few EC2s, some Lambda functions, and then I go and I build this thing, and I hit my Terraform plan and apply and build it initially in a dev environment, and then eventually it gets into production. And what happens today with CSPM tools, cloud security posture management tools, is that they'll look at your prod environment, or maybe sometimes even your staging, and they'll look for security mistakes. So they'll tell you something like, oh, you've spun up an S3 bucket, but you didn't turn on logging, or you didn't turn on MFA delete, or the bucket is public. Of course, that's the most common example. Or maybe your RDS is not encrypted. And getting these kinds of notifications after something is deployed is a big problem. And the reason it's a big problem is that, first of all, it's in production, so you're already exposed. That's a problem, especially from a compliance perspective and auditing. But I can tell you as a developer, and I've been a developer for many years, it's very frustrating, because what happens is you get a JIRA ticket from the security team that says your bucket is not configured correctly, your IAM policy is too wide, your RDS is not encrypted, you need to fix it now. And you as a developer, you're already working on something else. You're already working on another project or another part of the application or whatever it may be. For you, it's now going back, trying to remember what you did there, looking back again at your code, trying to understand, how to fix whatever needs to be fixed. And a lot of times you'll find out that fixing these things is very painful. A very, very simple example is the description of security groups. So when you create a security group in Terraform, by default, we'll set the encryption to manage by Terraform. And then a CSPM tool will come along, look at the security group and say, the description is no good. The description needs to be very specific. Go fix the description. And you're like, fine, I'll go in, I'll put in the description and whatever it needs to be to satisfy my security team. The problem is that when I'm editing a description, it's now going to recreate the security group and everything it uses. And so a minor thing like fixing a description of a security group can be a massive amount of time in Terraform plan and apply, a lot of testing, a potential outage for my application. And all I need to do is fix just a string in a resource.
Just metadata, right?
Yeah,
which
metadata.
begs the question: why the hell does Amazon make us destroy the security groups and change the description? It's the bigger question.
It's crazy, right?
We encountered that in our modules. We were like, hey, let's just finally fix this bad description. I think we were referring to like it was a copy and paste mistake. It said like MongoDB and it was instead Postgres, and just changing that description forces a recreate.
Yeah. Just a small thing, and to us, people who deal with code, you're mind boggled by like, why is this happening? But the fact is that it is, and so when somebody finds a security issue through those tools, it is very frustrating for developers, infrastructure developers, any way you'd want to call it, to fix these things. And so there is, over the past year and a half, we've started seeing tools and technologies focused on finding these issues early in the process. So instead of waiting until that last moment of finding problems in the cloud environment, let's find them early when we're still writing our code and building our plans, et cetera.
So there's a number of open source tools that do this, right? So what are those specifically?
Yep. So we've seen Chekhov, who a lot of people are familiar with.
Popular.
Chekhov is popular, made by Bridge Crew. They released it in December of 2019, which is just a year and a half ago, if you think about it. It feels like a decade ago with COVID and everything. And how long
they've already been acquired since then.
Yeah, and they've been acquired by Palo Alto Networks, and congratulations to them for that. So you have Chekhov, you've got TFSec, which is also a great product. You've got Kix, who a lot of people haven't heard of before.
Yeah,
but
what's that?
It's KICS. It's made by Checkmarks. And it's an interesting one to look at as well. There's obviously all the OPA and OPA based things. And so, kicks like that. Exactly. So there's obviously all the OPA based things, whether it's, the few kind of usage of it or just direct usage of OPA or anything else. So there's basically a whole bunch of different open source tools. Now, what all of these tools do is they focus on what's called static analysis. So they look at your code and they analyze whatever issues you may have in your code. So for example, let's say, if we go back to the example earlier with the security group, they'll check that you actually have a description for your security group. And they'll tell you about it before you actually try to build it. Or if you're using an RDS, they'll tell you your RDS is not encrypted. And you can fix it before you push it into production. And that way you're avoiding all these issues from the CSPM. Now, as I mentioned, we were building our own cloud environment. And so we started playing around with these tools. We started playing around with Chekhov and TFSec. And again, this is about a year and a half ago. So it was kind of early on for them. But we found a bunch of issues as we were dealing with it that were bothering us, and we decided to solve. Being the technical team that we are, we'll solve it for ourselves.
This is easy. I can fix this.
Exactly. I mean, it's code, right? We've been doing code for years, so let's just write some more code. It's a lot harder always than what it seems like. And so we decided to go and build our own technology for dealing with this. And we decided that our technology, instead of being just static analysis and looking just the code, it would look at both the code and the live environment that you have. And there are specific examples for why you would need this. Actually, do you mind
yeah, you can share your screen. Also, when you say code, are you referring to the HCL code? And I mean, then you are doing static analysis as well, or because my understanding was you did something different than static analysis.
We do static and dynamic, so we do both of them actually together. Okay. And I'll show you a very simple example here. Can you see my Visual Studio?
Yep.
Yeah. Okay. Cool. So this is an example of some Terraform code, a very simple example. And what I have here, I'm building a DB subnet group, and I'm building a database instance. And with that database instance is using that subnet group and is using a security group. A security group basically from a VPC. Now, notice how in my code, I'm using the IDs directly of these cloud resources instead of generating these resources in my Terraform or using something like a data source, which oftentimes you'd want to use. Now, we've seen a lot of users actually use this. So we've seen a lot of users create resources in the cloud, either manually through the console or maybe in another set of Terraform code, or maybe even CloudFormation. So they create the resources separately, and then they try to use those resources within their Terraform code here. Either they use a data source or they're using the IDs directly, like I just did here in this example. Now, when you do what's called static code analysis, you don't know what these IDs mean. So if I'm just looking at this code, and if I run Chekhov or TFSec or Kix or any of those tools, they'll see the subnet IDs here, but they don't know what they mean. They don't know how those subnets are configured. And so what we saw is that this caused these tools to miss a lot of issues that should otherwise be detected. Okay. Now, the flip side is also correct. So in many cases, we found that the existing tools were actually identifying issues that didn't exist simply because they didn't know what were the configurations of these various resources. So they didn't know, for example, if this subnet has public IP address enabled or disabled, where it kind of it automatically generates it for resources. Or they didn't know if this security group is the default security group and what rules does the security group have. And so it made mistakes in both directions. So it had a lot of noise and false positives, and it also had a whole bunch of false negatives. Now, if you look at the world of doing security analysis for code in general, what people know as application security, this kind of problem has been solved. And the way that they solved it in the world of application security is they started applying what's called the dynamic analysis, which means looking at how your application is actually running instead of just looking at the code. And the really advanced tools do both static and dynamic analysis together. And so we decided to do that. So the way that Cloudrail works is it will look at your Terraform plan. It will also look at your live cloud environment, and then it will merge the two together. And then after merging the two, will it actually run the rules? So if we look at this example here, Cloudrail will look at this, see the security group you have here, find the security group in your live environment, pull the details for the security group, and determine that the security group is actually the default security group in the default VPC. And we'll tell you, hold on, you're deploying your database into the default VPC, and you shouldn't be doing that.
Makes sense.
Yeah, so I wanted to pause here. Is this making sense?
Yeah. Basically, you're operating on a split view, or you don't have all the information if you're just doing static analysis, and then trying to bridge the gap just using the current tools available is pretty hard.
Exactly. So if
we
take
go
ahead.
Yeah. So one of the things I think would be helpful then to understand is now, like, I think a strong case has been made for like why would one want to do this. So let's go into a little bit how you'd actually now run Cloudrail as a CLI tool.
Sure. So we built a demo account in Cloudrail, but also a demo AWS account and a demo Azure account. And of course, for the demo AWS account, which we've started building over the past week for these purposes, we're using the cloudposse module. For example, you can see here for creating users. And I even contributed to the module, to the README,
Thank you.
to the README of the module.
Okay, thank you.
Yeah, Matt approved my contribution. And so we built an example here. And the way this GitHub repo is set up, we're using GitHub Actions. And in the GitHub action, we have CI and we have the deploy side. And within CI, what we do is we do the Terraform init and the Terraform plan. And then we pass this plan over to Cloudrail. So Cloudrail has a Docker container as a CLI. And we wrapped it with a GitHub action. And what it gets is the plan itself, the plan file. It gets, of course, the Cloudrail API key. Cloudrail is SaaS. It gets the cloud account that you want to do it against, and then, of course, the working directory. And what Cloudrail does is it takes the plan, it reruns the plan with something called a custom Terraform that we built, which I think would be pretty cool to get into if it interests the audience here. But we basically run it through a custom Terraform that takes the plan, adds a lot of contextual information to the plan, and then filters the plan down. So as we know, plans have a lot of sensitive information. They can have database secrets, they can have keys, certificates, depending on how you built them, they can have a lot of very sensitive stuff. And so the way that the Docker container works in the CLI is that it takes the plan, reruns it for the custom binary, and then filters it down drastically only to the information that we need, which removes all of the sensitive stuff, and then it sends it to the SaaS for now.
Is this part of your solution, the open source? It just feels a little bit sketchy, right? Like taking that plan file, sending it to some third party and not knowing, like it's Scout's honor otherwise, right?
Yep. And so we're very aware of people's desire to see, okay, how does it work under the hood? This repo you can see is currently private, but it's in the process of becoming public. We're continuously working on it.
Cool.
You can see why actually there's a README. And so we're gonna make this public very soon, along with a few other components that we have, because we believe very much in transparency. We believe very much in putting the information in front of people, not hiding behind anything, and showing how we build things. It creates trust, and also so maybe somebody will have contributions and ideas things that we've missed.
Is that the same for the custom Terraform that you're using to augment or enrich that plan for the analysis?
That's a great question. So the custom Terraform is actually something that we're working on making public as well. And the custom Terraform, this is a fork of the main Terraform core binary, but we've modified it to fit our needs. And so we actually have a custom Terraform 0.12, custom 0.13, 14, 15.
1.0, come on.
We're about to. It's actually, I saw the ticket being worked on right now. So we're about to have the 1.0 too. And then of course there's going to be the 1.1, etc.
No, this seems to like, I don't know. Every time I've seen like some fork of some project that parallels it, it seems like a big endeavor. Are you taking steps to kind of upstream some of those changes or get them accepted, or what's the long-term viability of that strategy?
Yeah, so it's what's known as a PITA. I don't know if we need to be like PG-13, rated R, or whatever on this call, but
pain in the arse.
Yeah, exactly. And yeah, it is, and our developers hate it. And we've been talking with HashiCorp to get it into their main build. And we're very open about what we did there, and actually we're working on a blog post to be more detailed about what we did here. And we would love for this to be part of the main Terraform tool. So we're hoping that they'll accept that as something to work on. But basically, to maybe kind of explain why we did this, the very, very basic example, very, very basic idea is that if you look at just the Terraform show output, the JSON output, so Terraform show.json, it's missing a lot of contextual information. So for example, if you want to determine that a specific RDS is using the default security group of a VPC, in the show output, you can't see that. You can see very minimal information. And so actually, I think I can pull up an example. 1 second. I think I have one here that I was working with.
Oh,
yeah.
we don't have to do that though. Or I mean, I just don't want to get derailed too far.
Yeah, I don't know, just because
This
again,
is the
audio.
augmented output of Terraform Show in your version.
No, this is the original version. So
Okay.
so if you look at, oops. So let's say I look at just this very, very simple Terraform code. Okay, so I'm spinning up a VPC, a subnet, and a security group rule. Okay, which I'm adding to the default security group. And I ran a plan already. And this is how the Terraform JSON looks like. And you can see that there's the rule, okay? And you can see some of the values. And nowhere in these values here does it tell you what security group this resource is going to belong to. Now, this information starts to become available a bit below under the resource changes. You can see here that it tells you that after it's going to spin up the VPC, then it will know what is the security group ID of that VPC, and then it's going to set it for the rule. Okay, so what's happening is that in the JSON output, you can't actually see what is the VPC security group that is being used by this specific rule. Okay, and we have tons of examples like the one here, which I can go into, and I'm hopefully going to go into the blog post, but. That's why we had to build a custom Terraform. There's no way to get this from a show, so we had to build our own custom show. And again, we're going to be very public about it in the spirit of transparency and openness that I mentioned earlier. And so yeah, I got a bit derailed. I'll go back to the example I was going to show here. So here basically it takes the plan, runs it through the custom show, reduces it down drastically, passes it to our SAS for analysis, again, without the sensitive data. And then the results come back in SARIF format, which GitHub supports. And so when you're opening a pull request, it will actually show you, so here's the code that I just showed you, Guy. It will actually run it in CI and reject it, as you can see here. Now in my specific GitHub repo, for some reason, the code scanning results are not showing, but I'm going to show you how it looks like in our web UI. But normally you'd see this in the pull request.
Any other pull requests open? Because I think that's the most interesting view from my perspective as a developer, just seeing it in.
See how it looks like? Yeah, I think in the action itself, you should be able to see this. Yeah, so in the action itself, you can see an example. So this is the SARIF output that we provide that GitHub parses, and then it shows you what your issue is and the description of the issue, and it points you directly to the code itself, to the part in the code. And then below that, you can see the remediation steps. So Cloudrail will tell you, this is what you need to do to fix the problem that we found.
That's cool. And
we do this, so we have the SARIF format for GitHub. We have JUnit format for CI environments that use JUnit. We have the SAST format for GitLab. And so we've built the different formats for the different CI and CD platforms. And so Cloudrail is just easy to deploy into any of them. So it's just, you can use the Docker container, you pass the plan, get the results, and the platform knows how to parse those results and show them to you.
So as a SaaS, what is is there a free plan, or free forever kind of plan where you can get started, and what are the limitations of that?
Yep. So first of all, we have static analysis and we have static plus dynamic. So when you register, you can actually see this up here, static and static plus dynamic. First of all, static is free forever for an unlimited amount. So if you only do static analysis without adding your cloud account and what we talked about earlier, then you have as much as you want. But the reality is that most people move into static plus dynamic analysis, and there you get 30 free assessments a month. If you're an open source project, you get unlimited free assessments per month. And this is all for perpetuity. So, you know, whatever amount of time you want to run with this. And we're very cooperative with a lot of projects out there. And so we're happy to give this for free.
That's interesting. Yeah, maybe it's something I can look into for a cloudposse. If some way we could do it for the open source modules for testing. Though, yeah, the dynamic though depends a lot on the current running environment. And I guess with our stuff, it's mostly, you know, always destroyed after. So I wonder.
I think you'll find that even when you're destroying things, there are resources that remain one way or another, or even configurations that remain. So for example, if you think about S3 buckets, you can configure a public access block at the account level. And when you're destroying your resources, you're often not destroying those configurations. And so they're still there. And that's one of the configurations that Cloudrail takes into account. So if you're spinning up an S3 bucket through Terraform, and let's say you put an ACL of public, Cloudrail will actually look at your public access block at the account level and see if you're blocking public ACLs. If you are, then Cloudrail knows that the public ACL.
Based on your context, gotcha. That's interesting.
Exactly.
Yeah, that's not obvious. Yeah.
Yeah, there's a lot of pretty advanced and interesting logic within the rules and the context of Cloudrail. Okay, so a few other aspects I wanted to talk about, and again, this is a technical audience. I'm digging into the technical aspects, and I must admit I enjoy this stuff. So all of our knowledge, all of our rules are in an open repository that anyone can look at, and you can see what we're building there. But one of the cool things I wanted to point out is that we built our context to be essentially an object model that all the different sources of content can map into. So for example, if we take AWS as just, you know, the common example here, if you think about an Athena database, we modeled the Athena database in our context, okay? And what that means is that you can parse Terraform content into the Athena database. You can parse CloudFormation stacks into the Athena database model here. You can parse Pulumi in the future as well. And so you can actually build the same set of rules for any infrastructure as code language that you have. Okay, so if I look at an example of a rule here, let's say, let's pick maybe an interesting one. Here's an EC2 S3. Actually, I wanted the role share, S3 role share, EC2 role share. In this specific case, this is a role that captures two EC2s using the exact same role. One EC2 is public and one is private, and it's a big security issue, but that is being captured here. But the interesting part is that this rule is built on top of our context model. And so it doesn't matter if you're using Terraform, CloudFormation, Pulumi, you know, any language you want. Any of those languages that we parse into our context model, the same rule will apply. And the same thing is also true to your live environment. So if you think about one of the big differences in static analysis versus dynamic is that in the existing static analysis tools, they have different rules for Terraform, different rules for CloudFormation, different rules for the cloud environment, for the live environment. Each rule is implemented multiple times. Whereas here you have each rule supports all of these. So it's one rule that's built. It supports your live environment. It supports your Terraform, your CloudFormation, Pulumi that when we'll support, etc. And so that makes for a far more consistent enforcement and consistent logic across your different environments, across any language you want to use.
So does this depend? Oh, well, so will this depend on, or how sensitive is this to changes then in Terraform itself? Like between, like historic now with 1.0, I guess it's a different situation, but before 1.0, how sensitive is it to changes in Terraform?
So we've seen some cases where there were issues, maybe less in the Terraform itself and more in the providers. So, sometimes over time in the providers, they had a couple of breaking changes. And what we needed to do is support both of them. So when we parse the output, we'd say, is it AWS provider version this? Okay, so we need to do this way. If it's AWS provider version, Y, then we need to do it differently. But we actually automatically test for this all the time. So twice a day, we have all of our tests run on multiple different provider versions and Terraform versions. They have specific versions that we set, but also it always downloads the latest one. And so let's say AWS provider comes out with a new version and it would break any of our code, we will identify it within 12 hours because we're going to auto download and run through all our tests using that that provider version. So it does break sometimes, but we catch it very early and oftentimes before anyone else actually gets to that.
So one of the hardest things I think is always with these policy engines is having an opinion developed enough to identify what the policies should be. I forget, we had an I remember now. I remember on the tacos office hour at the end of last year, all these platforms like Scalar and Sentinel and I guess Terraform Cloud and Spacelift, they have policy engines largely built on OPA, but the exercise of coming up with what should our policies be, that's always left up to the end user. So where did you get the inspiration for all of these policies that you have today? Where'd those come from?
So first of all, the original batch came from various kind of standards like CIS. So if you think about it, there's AWS CIS. I'll just show it here for those who might not be familiar with it. There's CIS for Azure, for AWS, for GCP, etc. And this defines kind of the main controls. And a lot of tools map to this. So for example, AWS config maps to this, but also some of the other tools. So the first thing you do is you support the list that is built by CIS, which is oftentimes just suggested by the cloud provider. Then you start looking at other regulations and compliance requirements like HIPAA, PCI DSS, HITRUST, and others, and you see what those require, and you add those also as rules. And then on top of all of that, there are the rules that customers actually ask for and want to see. So, for example, some of the rules that you are seeing here in these lists were actually asked for by users. So was it here? No. But basically, you would open an issue. You can open your own pull request. You can write the rules if you'd like. We're going to have a hackathon around that, by the way. People writing rules for Cloudrail based on their own needs and contributing them, or at least sharing them. So that's going to be a really interesting one. So you can add whatever you want. And what we do is we just continuously expand the context. So there's documentation for the context, so you can see what services we cover, what objects we cover within those services, what fields we're pulling. You can see examples of rules, so you can kind of get an idea of what you want to write. So it's pretty cool. Just, again, like as a technical guy, see that. So one area that we're working on and is going to be released soon is around drift detection. And so something that's become very hot recently, various tools started providing drift detection. There's obviously also drift control, which is a very cool tool.
CTL, the open source tool.
I pronounce it drift control. I don't know I think that's how they pronounced it.
No, that's probably, CTL is the control, the standard suffix for that.
And I gotta say, I love their logo, and they're like the London
Mind the Gap.
Mind the Gap and the London Underground. It's genius between the code and the platform. I gotta tell you, it's genius. I love it. I told them that. I think they gave me a shirt.
I want to have them on. I want to have them on office hours too.
They're great. And so they built a tool that you can run. And it will take your Terraform state or multiple states and it will compare it with your live environment. And so it's a step towards what I was referring to earlier with the whole dynamic analysis of not just looking at the code, not just looking at the state, but looking at how they two relate to one another. And drift detection in general is something that's getting a lot of focus from our users and in general. What you're going to see from us in the coming weeks is actually drift detection built into Cloudrail. So you're going to see in the view here, just like, when we go into here, you can see what issues Cloudrail found, and it can point you, to the specific resources, et cetera. You're going to see in here the drift that we found. And you're also going to get alerts when we find drift. So let's say you've defined a database and you decided to enable a feature like the performance logs. And somebody went around your process, went into the console and enabled it directly there instead of through Terraform, the way that they should. So normally you wouldn't know. Normally, the way you would discover this is when you do the Terraform refresh, Terraform plan and apply, you get refresh, then it tells you. Now with 0.15, actually, it's a bit more informative. It will tell you, oh, by the way, somebody changed a resource, so I'm going to change it back. And that's a kind of a really bad way of finding out that somebody's messing around with the environment. And also people ignore it.
It's also harder, right? The more time that elapses from when that change made, the higher the likelihood that the person who made it forgot, moves on, etc. So yeah, catching drift early is the best recipe.
Yep. Yeah. And so you're going to see that in a few weeks from us. You're going to get basically, so we're going to run once an hour, we're going to run our drift detection, comparing the Terraform plan you provided us to what we're seeing in the cloud environment and telling you if we find drift. And if we find drift, you're going to get a notification. And so if somebody made a change, it's going to be within 60 minutes and on average 30 that you're going to find out that somebody messed around with your live environment directly. And so you can immediately, obviously ask around, hey, who messed with it? But also you can stop the Terraform applies, the CI that you have, just stop, fix it, fix the code, sure you're aligning your process.
It seems really hard to do because a typical cloudposse customer has like 300 to 400 states for all their different components. And in order to detect the drift, you need to make sure that it's not in any of those 400 states. Is that what the product supports? Okay.
Yep. Yeah, exactly. And that's been one of our challenges from a technical perspective that I'm happy to say that we solved. And that is mapping which plan is responsible for which resource. So being able to say, I saw this plan, and in this plan, it created and managed these ARNs. Like if we just talk about an AWS example, these ARNs is what I saw. Okay, so this plan manages it. So when I try to calculate drift, I'm going to do it between this plan and these resources. Then this other plan manages these other ARNs. So for these resources, I'm only going to look at that plan. So we actually had to build a mapping to understand where to look and what to compare for that exact reason.
Yeah, go ahead, Joaquin.
No, I was saying I built a graph database to do the math.
Yeah. So first of all, the entire Cloudrail mechanism runs on a graph database because a cloud environment is best described as a graph.
What technology are you using for that, out of curiosity?
We built our own on top of Python. We found it to be the best fit for us and the fastest. Okay. Developers.
Yeah.
We build our own.
Why reuse what you can build yourself?
Yeah. Although I'll be honest with you, we do reuse quite a bit, and then we also contribute back. Some of you guys might have heard of a tool called Cloud Mapper. So we needed a capability like that. We took Cloud Mapper, but then of course we found out that we need a lot more than what Cloud Mapper does. And so we open sourced it as dragoneye. It's based on Cloud Mapper. It supports Azure as well. It will support GCP as well. But as developers, you kind of take and you build. But back to the original question. In the graph, we specifically mark where each resource came from, or if it didn't. If we didn't see it, by the way, we'll tell you. So we'll say we, 60% of your environment, these resources we've never seen in any plan. So either they're not managed in infrastructure as code, or you just didn't integrate us into all of your CI/CD processes for.
And is this going to be, I guess initially it's just going to be Terraform specific, so it's not going to work like with your CloudFormation templates, or?
It will. So we're going to be releasing both very closely timed, and so the drift detection is going to work on whether you're Terraform or CloudFormation.
Wow, that's pretty cool. Michael Jenkins was asking if you run into any API throttling while pulling the state for so many live resources.
Yes, we do. And if you look in dragoneye, you're going to see that there's the backoff mechanism that is required. So there's the Boto3 backoff mechanism that's built by AWS, but then there's also logic we had to add on top of that, because we run into these issues, and what the best solution that AWS has for you is take a step back and kind of in an exponential manner wait a certain amount of time before you try again. So that's built into dragoneye.
And dragoneye is actually what you're using then as part of the commercial product on the back end?
Yes, it's a component. And so you'll see all the time work being done on this because this is what we use in the product itself.
That's cool.
Yeah. And by the way, Michael, you got a great last name.
Yeah.
I love it. You probably heard that before. And so I think if I kind of bring all of this together and wrap it up and kind of to the title of this meeting, the Terraform continuous compliance, the idea is that if you find issues in your infrastructure as code, Terraform, CloudFormation, et cetera, if you find the issues when they're still code and you fix them when they're still code, and on top of that, you also identify any drift, and if anybody plays around with your console and with your environment, your live environment through the console, then you can now achieve what's called continuous compliance, which means you're always compliant. So just like you have continuous integration, which means you integrate your code all the time and you test it as you're integrating it, or continuous deployment and continuous delivery, which actually means you're setting up your environment all the time and you're pushing to production regularly, or at least to the artifact database. With continuous compliance, you're all the time verifying that you're compliant. And when you're not, you stop it before you become non-compliant and you fix it, or you identify it really quickly, like in the case of drift detection, and you fix it really quickly. And so with doing all of this, we can actually create an environment that's consistently in compliance with the organization's requirements. The security people are happy because everything's good and secure. Developers are happy because security is basically not bothering them anymore. And it's following the tools and the processes that we've built as software developers over the past couple of decades with CI, CD, DevOps, Jenkins, et cetera, et cetera. So that's why, at least I think it's a big win-win. And we have an entire team working on Cloudrail at Indeni, all fantastic technologists, and we're always looking for more. So if you're hearing all of this and you're like, wow, I want to be part of it, then hit me up on the Slack, on the SweetOps Slack.
Yeah, you'll find Yoni on there all the time. He's been super helpful answering questions for others. So thanks, Yoni, so much for taking the time to present today. We're almost at the end of the hour here. Just a few more minutes. So I wanted to take a moment to help people find out where they can go next if they wanted to check this out. Kick the tires. I know I'm really excited personally about that drift detection. I think that fills a need for a lot of our customers to identify that sooner. And there's no tool right now that really does a good job for that drift detection. So excited about that. Let's see. So you shared these links with me earlier that people can go sign up at web.cloudrail app. And I'm sure if you guys hit up Yoni on Slack, he can probably hook you up with some extended trials. Maybe I'm just putting words in his mouth. I don't know. But if you want to really evaluate it, Yoni will work with you, I'm sure.
And also, if you're a SweetOps on the SweetOps Slack and you sign up after you run your first scan with Cloudrail, let me know and we have something nice we're going to send you.
Yeah, that'd be cool. Also, you have this test case, which will make it easy for anyone who wants to just simulate it on their own, hands-on lab kind of. And that's the second link here, the Cloudrail demo.